So this question is saying that Keyshawn drives 300 miles in twice the time it takes Shelby to drive 240 miles. Shelby's speed is 30 miles per hour greater than Keyshawn's speed. So what is the speed and time of each? So in order to solve this, you can set up a system of two equations. And the reason you know to do this is because it's mentioning Keyshawn's and Shelby's speed and time relative to each other. So given the information they have, we know that distance equals rate times time. So we know that Shelby, if you look at the first step, K and S are for Keyshawn and Shelby. So under Shelby, he goes 240 miles equals time times speed. So however long it takes times however fast he's going. And for Keyshawn, 300 miles equals 2t. It's 2t because if you look at the problem, it says that it takes twice the time as Shelby times S minus 30. And the reason that it's S minus 30 is because Shelby is driving 30 miles per hour faster. So once you set up those two equations, you want to solve for one of the variables and plug it in to the opposite equation. So the bottom equation is much easier to work with if you see Shelby's equation. So what I did there is that I solved for t. So I divided s on both sides and got t equals 240 miles divided by s. Now that I have a figure for t, I plug that into the first equation, Keyshawn's equation. So if you look at step 3, that's what's going on there. The 300 miles equals 2t. Instead of t, I put 240 miles divided by s times s minus 30. And then after dividing both sides by 2 and then distributing the 240 over s and then cross multiplying, you get s equals 80 miles per hour. So in order to get t, I just plug that back into Shelby's easy equation. So 240 miles equals t times s, 240 miles equals t times 80 miles per hour, and t equals 3 hours. So now that you know it takes Shelby 3 hours and 80 miles per hour, you know that Keyshawn's time is twice. So Keyshawn's is 6 hours and his speed is 30 miles per hour less. So it's 50 miles per hour. And if you want, you can plug them all back into the original equations to make sure that everything is correct.